When we look into the vastness of the universe, at some point we reach the limit of what can be observed, a limit that seems impossible to overcome. Have you ever wondered what might lie beyond that? This boundary, the edge of the universe, is expanding ever further and faster in all directions. But what incredible force is capable of expanding an entire universe? Now, I want you to let time run backwards in your mind and observe the universe. It gets smaller and smaller. The denser it gets, the hotter it becomes. Structures such as galaxies, stars, and planets break apart. Their elements decay into hot plasma. The compression continues until even the dimensions, space and time, merge into a single-dimensional point of pure energy, a singularity. You have just discovered the origin of the universe, the Big Bang. But insurmountable boundaries, accelerated compression, and incredible densities of energy remind us of something else hidden in our universe. Right. I'm talking about black holes. And with that, I ask the existential question, are we living in a gigantic black hole? Stay tuned and find out. Carl Schwarzschild, a German physicist, found a solution to Einstein's field equations in 1916 that described a spherically symmetric mass in space. This solution, known as the Schwarzschild solution, predicted the existence of what we now call black holes. These cosmic enigmas are captivating not only for their ability to devour everything in their vicinity, but also for the intricate structures and mind-bending physics that govern their existence. They come into existence through the dramatic demise of massive stars. When a star exhausts its nuclear fuel, it undergoes a supernova explosion, leaving behind a dense core with gravitational forces so intense that not even light can escape its grasp. This collapsed core forms the heart of a black hole. Now, what triggers a supernova explosion? The explosion occurs when the pressure generated by nuclear fusion diminish and a massive star can no longer support itself against gravity. This is followed by a catastrophic collapse that leads to the implosion of the entire star. As one ventures closer to a black hole, an invisible boundary known as the event horizon marks the point of no return. Cross this boundary, and escape becomes impossible. Keep the event horizon in mind, as it will play a mind-bending role later in the video. So be curious. Here, time itself is bent, with the seconds outside the event horizon stretching to eons for an observer falling into it. This is called time dilatation. Some even assume that time comes to a complete standstill at the center of a black hole. However, this raises the question of whether anything can reach this point at all. But hold on, it's getting even better. The center of a black hole, the so-called singularity. Here is where the magic actually happens in our theory. A point in space where gravity becomes infinitely strong and the laws of physics as we know them break down. In this infinitely dense region, the very fabric of space and time is warped beyond comprehension. Well, what happens to matter that gets pulled into the singularity? Matter approaching the singularity is stretched and compressed into an infinitesimally small point, a process known as spaghettification. Unbelievable what high-density mass can do with its incredible gravitational effect. If you're interested in how mass gets its gravity, you should also watch my video on the discovery of the Higgs boson. But let's continue with the singularity. It's an extremely condensed point where the known laws of physics break down, challenging our understanding of the universe itself. But the question arises, can the concept of an infinitely condensed point truly exist, or does it imply a breakdown in our understanding of the laws of nature? While infinities are often considered problematic in physics, the singularity within a black hole challenges our conventional understanding. It suggests that under extreme conditions, the laws of nature may indeed behave differently. As we delve into the heart of a black hole, the clash between general relativity describing gravity on large scales, and quantum mechanics, governing the behavior of particles on the smallest scales, becomes inevitable. Current theories struggle to unite these two pillars of physics in the extreme conditions of a singularity. By the way, with a thumbs up, you show the YouTube algorithm that this video is worth showing to others. Subscribe to the channel for more and to help me growing. One of the most perplexing aspects of black holes is the information paradox. According to classical physics, information swallowed by a black hole is lost forever, contradicting the principles of quantum mechanics, which assert that information cannot be destroyed. So what is the solution? Some theories propose that information may be encoded in subtle quantum correlations between particles emitted during the black hole's evaporation through Hawking radiation. But it keeps going nuts. Exploring the mysteries of black holes has led scientists to consider the possibility of hypothetical tunnels in space-time that could connect distant parts of the universe or even different universes altogether. Might wormholes offer a glimpse into alternate realities or connect disparate corners of the cosmos? Yes, wormholes, if they exist, could provide shortcuts through space-time, challenging our perception of distance and potentially allowing for travel between different regions of the universe or even to entirely different universes. Let us now come one step closer to our original question about universes inside of black holes. None other than the brilliant scientist Stephen Hawking proposed the theory of a cosmic connection between the depths of a black hole and the explosive birth of a new universe. Well, is it plausible that the compressed mass within a black hole could undergo a transformation leading to a cosmic rebirth? The idea that a black hole could give rise to a new universe is a concept that emerges from the complexities of general relativity. This hypothetical process involves a rebound or bounce, where the collapsed mass of a black hole undergoes a transformation, initiating the expansion of a new cosmos. This process spans its own dimensions outside our universe, where the laws of physics are uncertain and may differ from those of our universe. Another intriguing concept involves the existence of white holes, theoretical celestial objects that theoretically expel matter rather than absorbing it. Some theorists propose that these hypothetical white holes could be connected to black holes, forming a bridge between a dying universe and the birth of a new one. And then the universe comes up with the next concept beyond our imagination: black holes as the key to the multiverse theory. The multiverse theory suggests that our universe is just one of many, each with its own set of physical laws. And this is where it gets truly fascinating. If black holes can indeed give birth to new universes, there could be as many universes as there are black holes. In our own universe alone, there are an estimated 40 quintillion black holes. Yes, you heard right. That's a 40 followed by 19 zeros. Assuming that black holes can also form in these universes, then this nested reality may go on indefinitely. What a mind-boggling theory. Well, the theory of universes within black holes opens up a possible explanation for one of the biggest unsolved questions in modern physics: the cosmic expansion and the origin of the so-called dark energy. Now, is there a connection between the relentless appetite of black holes and the accelerated expansion of our universe? This intriguing hypothesis suggests a cosmic interplay where the gravitational pull of black holes serves as a driving force for the expansion of the universe within itself. As black holes grow in mass, their gravitational influence extends far beyond their visible boundaries. Anything that strays too close is drawn inexorably toward the dark heart, contributing to the black hole's insatiable appetite. The more mass it unites, the greater its gravitational pull, which in turn causes it to suck in even more mass. This leads to accelerated growth, which, interestingly enough, also applies to the increasingly rapid expansion of our universe. Coincidence or astonishing connection? Much like a black hole accumulating mass as it attracts surrounding matter, the universe may be expanding as it draws in energy from the outer cosmos. The matter consumed by a black hole doesn't simply vanish. It undergoes a transformative journey. As it spirals toward the singularity, a fraction of its mass is converted into energy, as famously described by Einstein's equation, E equals mc squared. Is this energy the mysterious and not yet well understood dark energy? In the quest to understand the nature of our reality, a mind-bending hypothesis has emerged. The idea that our three-dimensional universe could be a holographic projection from a two-dimensional surface. And this is where, as promised, a phenomenon already mentioned comes into play again, the event horizon. What exactly is the holographic universe hypothesis, and how does it challenge our perception of reality? The holographic principle suggests that the information within a black hole is not lost, but is somehow encoded on the two-dimensional surface of the event horizon. This provides a potential solution to the long-standing information paradox. The holographic principle delves into the quantum realm, where particles become entangled and exhibit instantaneous connections regardless of distance. This quantum entanglement is thought to be the thread weaving the fabric of space-time and plays a crucial role in the holographic nature of our universe. Questions arise about the nature of the information stored on event horizons and the potential existence of firewalls at the boundary of black holes. Okay, wait, what are black hole firewalls? And how do they relate to the holographic encoding of information? Black hole firewalls are hypothetical, intense layers of energy near the event horizon. And the existence of firewalls is a topic of debate among physicists seeking to understand the intricacies of black hole physics. If black holes give rise to new universes, what sparked the creation of the very first universe that birthed the initial black holes? The idea of black holes as cosmic creators introduces a fascinating loop in our understanding of existence. Each universe, born from the depths of a black hole in a previous cosmos, becomes a cradle for new black holes, perpetuating an infinite sequence of cosmic birth and rebirth. As we navigate the cosmic labyrinth, the question of the ultimate creator remains. Whether framed within the context of black holes birthing new universes, cosmic loops, or the multiverse, the journey to understand the origins of everything continues to be a captivating odyssey. Thanks for watching. That's it for the video. If you want to keep going, here are 2 more. Subscribe for more videos, and don't forget the bell. You're still here? Come on, go for it and watch another video.